What's up, guys? Welcome. Kevin DeBruyne, the fit rocket scientist here. Today we are hunting for exoplanets. What's an exoplanet, you say? So an exoplanet is a planet that's orbiting another star other than our sun. So NASA released some really cool exoplanet posters. You guys may have seen these. This is Kepler 186f. They're just trying to visualize what it would be like over there if you're standing on these planets. Another one is this one right here, Kepler 16b. It's a planet that has two stars, so it's like your shadow always has company. Just a cool way to kind of visualize what some of these exoplanets are like. So how do we find exoplanets? Well, there are three main ways to find these planets that are orbiting other stars. One is called radial velocity, second one is called transit photometry, third one is called microlending. So I'm going to give you just a really brief overview of what each of those are. So radial velocity is actually looking at a star and seeing it wobble a little bit. You know, if it's around another star, it's just going to be wobbling. Do not judge me, I don't dance, okay? But you have to throw the wobble in there, right? So if we have a planet, the sun, a star, and a planet, they're actually orbiting a central point, somewhere maybe in the center, could be actually inside the sun itself, but it's called the barycenter. So the star will wobble a little bit, wobble a little bit, and it's going to be changing its spectrum. So when we look at it in a telescope, you're going to be able to see different parts of blue and red shift lights of fingerprints to show you that there is a planet making that star wobble a little bit. All right, the second one is called transit photometry. This one's probably the easiest one to understand, is that the planet will literally pass in front of the sun and will cause the dimness, or pass in front of the star and drop the brightness a little bit, causing it to dim slightly. So if you come in, you're obstructing part of the source light coming out, and it causes it to dim. All right, so that's the second one. Third one is called microlensing, or gravitational lensing. This one's a little bit more complex to understand, so I'll try and break it down really simple for you guys. It's also known as gravitational lensing. So what happens is when you have a massive object, this thing here called the lens, that actually bends the light of a bright background, which is known as the source, back here. So these are two stars, think of it like that. It bends the light around it, so it'll bend the light and actually create multiple images, mostly two images. So it's just bending of gravity's bending the light around the two stars, creating a secondary image. All right, and if there's a planet around this star, it will bend the light as well and create a third image temporarily. It could be a couple hours, minutes, weeks, depending on how big the planet is compared to the sizes of the stars, what its orbit's like, and there will be a third image of brightness that we see when we're observing it with telescopes, and that's the third way of microlensing to detect other exoplanets. So, quick recap, you can have the wobble, you can get the radial, which is the star wobbling back and forth, radial velocity. Second one is the transit photometry, the planet passes in front of the star, causing it to dim a little bit. And the third one is the gravitational or microlensing, where the gravity of the stars actually bend light around each other, and the planet can also produce more bending of the gravity to create more images when you observe it through the telescope. So that's how we detect exoplanets. So let's go hunting.